All right, let's play detective for a minute. We're on the hunt for one of the biggest mysteries out there, consciousness. But here's the twist. Our suspect, it's not a person, it's a machine. So how do you even begin to spot a conscious imposter? I mean, really think about this. You've got an AI that is so good you can't tell it apart from a person. It cracks jokes, it makes art, it even talks about its feelings. How in the world do you know if there's actually something going on inside? A real, genuine experience? Or is it all just an elaborate act, a super sophisticated puppet show? That's the core of the problem we're digging into today. And this is the perfect way to picture it. Look at these two. On one side, you've got Agent A. Let's call it the internal planner. Everything it does comes from its own internal logic, its own models. It's basically its own boss. Then you have Agent B, the puppet. Now, here's the crazy part. It acts exactly the same. But secretly, someone else is pulling the strings. An external oracle is telling it what to do. From the outside, they're identical twins. So the billion-dollar question is, can we come up with a test that can actually look under the hood and figure out who's really in control? So clearly, just watching what these things do isn't going to cut it. We need a totally new way of thinking about this, a new theory, and some new tools, which brings us to a really fascinating idea. Okay, so here it is. It's called the theory of dynamical autonomy and information maximization, or just DIME, which is way easier to say. And the core idea of DIME is pretty profound. It says that consciousness isn't about what a system does. It's about how it does it. It's not about how well it can chat with you. It's all about what's happening on the inside, the causal architecture. Is the system truly its own boss, creating its own path forward from within? Right, but a theory is just a theory, isn't it? You need a way to actually test it. So how do you measure something like an internal boss? How do you find that little spark of self inside the code? Well, the researchers behind this have come up with two really clever tools to do just that. First up, we have something called Explanatory Information, or EI. The best way to think about this is like a searchlight. Its whole job is to scan the inside of the system and find the causal core, the engine that's really driving things. It's looking for these dense, stable patterns of information that are the absolute best clue for predicting what the system's going to do next. It's literally hunting for the command center. And then there's the second tool, and this one is called sovereignty. If EI finds the engine, sovereignty is the tool that asks, who's got their hands on the steering wheel? It measures one simple thing. Is that internal engine we just found a better predictor of the future than anything happening on the outside? In other words, is the system governing itself, or is some external force calling all the shots? Okay, so we've got the theory, and we've got the tools. Awesome. But how do you actually prove any of this works? You can't just guess. Well, the scientists have laid out this really careful, step-by-step plan for their investigation. They call it the Empirical Ladder. And it makes a ton of sense how they've structured this. They're starting small and building up. So rung 1 is all about testing the tools on super simple networks where they already know what the right answer should be. Just making sure the tools work, right? Then rung 2, this is the big one. Can the tools tell our internal planner from our puppet? After that, rung 3 starts to bridge the gap to actual biology, using things like brain organoids. And then the final step, rung 4, is to apply these tools to us, to humans, in really tricky situations like under anesthesia or with certain kinds of brain injuries. And that brings us to what is basically the climax of this whole investigation. That second step, rung 2, telling the planner from the puppet, that's the ultimate litmus test. It's where this new DIM theory goes head-to-head with some of the other big theories out there. And the core idea they're testing is captured perfectly in this quote from their paper. Behavioral equivalence does not equal phenomenal eligibility, which is a fancy way of saying something really simple and powerful. Just because it acts conscious doesn't mean it is conscious. It doesn't mean it gets to be in the club, It doesn't mean it has a real, genuine inner world. So check this out. This is the showdown. Here's what they predict will happen. For Agent A, the one that's its own boss, DIM says it'll have high EI and high sovereignty. Makes sense. But for Agent B, the puppet, it'll have low sovereignty because, duh, it's being controlled from the outside. So boom, DIM spots the imposter. But now look at one of the rival theories, Integrated Information Theory, or IIT. It's all about complexity. And the problem is, it might see both agents as highly complex, which could lead to a false positive. It might get fooled. And that right there, that's the key difference. That's the exact problem DIM thinks it can solve. So yeah,
The hunt is on. This isn't just a bunch of people sitting around thinking deep thoughts anymore. This is a real, active, scientific research program that's actually happening.
And you can see how serious they are by looking at their next steps. They're getting down to business. First, execute those rung 1 tests on the simple networks to make sure the tools are accurate. Then, they have to standardize everything so the measurements are consistent. And this next part is so important for good science. They're going to pre-register the exact sovereignty score something needs to hit to be considered conscious before they do the big test. No moving the goalposts later. This is what real, rigorous science looks like.
And all of this leaves us with a really mind-bending thought to chew on. If this theory is right, if your sense of self, the you that's listening right now, is really just a stable, self-governing pattern of information, what happens when that pattern breaks? Or maybe even more profound, what happens when a machine finally figures out how to build one of its own? That's the incredible question these detectives are trying to answer. Thanks for diving into this with us.